This chapter, or this section, this will end our chapter. We will be having a test soon after this. Now that we've talked about some of the patterns or the way the patterns are formed, we're going to actually look at some of those zones where those patterns arise at. And one of the first ones here, or the first one that we're going to look at, is the Intertropical Convergence Zone, also known as the ITCZ. Another name for this is the doldrums. It was given this name because of the sailors as they sailed through these areas. The weather most of the wind is vertical, so their boats wouldn't sail very well. Sailing boats need horizontal wind. They're designed to take advantage of it, whichever direction the wind is blowing, as long as it's not vertical. And in the ITCZ, it is. It's actually going up. This is near the equator. And the regions around the ITCZ usually have a tropical climate because they pull in moisture from over the water as well. A little ways away from that, 30 degrees north and south latitude, we have the horse latitudes. Most of the Earth's deserts are located in or near the horse latitudes, and this is where we have falling air. It's still vertical, it's going down. You may remember the Hadley cell from 0 to 30 degrees, and if you remember that, the air was rising over 0, falling at 30. These are those areas and what the wind has the effect there. Why they're called the horse latitudes? Not because there's lots of horses there, but because the sailors, as they reach these areas, it would not be uncommon for their ship to go calm, for them to be stranded really in the water for days or even weeks, depending on time of year and other effects. And so as they were stranded in these areas with no wind, they would have to start rationing water. Humans had priority over cargo. Horses were cargo. And the horses, as they either died or went mad from thirst, had to be pitched overboard. And so the sailors came to associate these areas with those horses and what they had to do with them. So the ITCZ and the horse latitudes have vertical winds. Now, in the region between those, from 0 to 30, we have the trade winds. These are winds that blow from the horse latitudes towards the equator. They probably got that name because a lot of the sailing vessels that were concerned with trade would use these winds to their fullest advantage. So, we have these trade winds, named after the ships that were doing trade. Now, go all the way north or south to the poles, and we have high pressure as the cold air drops down over that pole, and it spreads out. Now, because of the Coriolis effect, these winds appear to come out of the east, and winds are named after the direction they are coming from, not the direction they are going to. So if it is an easterly, as it is with the polar easterlies, they are coming from the east and moving westward, or at least that's the way it looks. And then if they're westerlies, they're coming from the west and moving east, which is in that region just below the easterlies. We have the prevailing westerlies. These are winds that blow from the horse latitudes towards the poles. And we see a shift between the westerlies and the prevailing westerlies and the polar easterlies around the 60-degree latitude mark. The reason why you hear me saying around or near is because these exact latitudes will shift from season to season. As the Earth tilts towards or away from the sun, we move away from the sun. We talked about a lot of those factors that contribute to how much heat and energy is located, and that will affect exactly which latitudes. Now, it will be near these. They won't shift very far away from them at all, but that's what we see. Now, jet streams are high-altitude winds. They are stronger than surface winds. And there are subtropical, there's polar front jet streams. Just it kind of depends on which latitude we're talking about, what kind of air temperatures we're talking about as well. Really, we don't utilize these jet streams except for aircraft and stuff. The jet streams can play a factor, especially if they shift significantly and start dropping colder air or even warmer air in regions that don't have those yet, creating high and low pressures. The locations and boundaries of jet streams vary greatly with the seasons and with weather conditions. However, the aircraft, like I said, take full advantage of that. And then we have an interesting effect here called Rossby waves. These are not winds, as we've been talking about them, but it is a movement of air in the upper area of the troposphere. In temperate regions, the upper winds follow a wavy path, slowly moving first towards the poles, then away, then back towards the poles, then away. The number of waves in a single circuit around the Earth varies from 3 to 6. In the summer, the waves tend to be shorter and shallower, allowing more waves to fit in there. Whereas in the winter, the waves are longer and deeper, so there's less of them. They are named after their discoverer, Carl Gustav Arvid Rossby. And usually waves are associated with the polar front jet stream, so those two are connected in that way. And then let's look at more localized effects. We've been looking at kind of global effects, global patterns. Now we're going to look at more local. Now keep in mind, local can still cover several hundred miles, regions of the regions, really. Like we have the northwest, the northeast, the southeast. Very different wind and climate patterns in those different regions. One of probably the most pronounced types of differences is the monsoon effect. This is a seasonal change in wind direction, often associated with rainy seasons and dry season. Monsoons or monsoons winds are winds that reverse their direction from season to season. Asia, especially the India-Pakistan area, has the most pronounced monsoons. India is pretty much famous for it. And something similar, we're going to look at a few diagrams here on the next slide, but something similar to a monsoon, or for similar reasons, just not as dramatic, are sea breezes and land breezes. All of these are associated with highs and lows. The sea breeze, also known as a lake breeze, because if it's a large enough lake, we still see this effect. Cooler air from over the water blows inland during the afternoon. And a land breeze is the opposite. A cool, gentle wind blows from the land to the sea, usually in the evening. Then also with mountains, we're going up and down here, but we see something similar based off of highs and lows, which we'll look at those diagrams in just a second. We have anabatic winds. These are upslope movements of air. They're moving from the valley up the mountain to the top. Katabatic winds are the opposite. They're moving from the mountains down into the valley. So now we'll look at those diagrams I've been promising. And this is for the monsoon. Sorry, it's a little bit blurry. But during the summertime, you have high pressure over the ocean. So that's cooler air coming down, pushing outwards towards the land. You also have stronger solar radiation over the land, causing hot air to rise. So you have this nice cycle of air. And because the air is coming down over the ocean and blowing on land, it's bringing a lot of moisture with it. So the summers in India tend to be very, very wet. That water accumulates next to the mountain, comes up against the mountain, can't cross it. It collects there until there's enough water. It starts raining, which happens often during this type of monsoon season. Now, pretty much the opposite happens in winter. We have the low pressure over the warmer ocean. There's weak solar radiation, so the land does not get as hot. Remember, the water holds the heat better. So we have high pressure from the mountains there onto the land, and that pushes the air out over the water, and so the wet, moist air moves out over the ocean, and that's where the rains and stuff happen. So we have a dry season for where the people live on land, versus the wet season is now out in the ocean. Now, the top one here is land and sea breezes. During the day, the rocks and dirt of the land heat up, creating a low pressure as the air rises. You have that cycle, the air moves out over the water, drops over the water, comes back in over the land during the day. Night, the opposite happens. The land cools off faster. That water holds the heat. So that's where the low pressure is, and the air moves upward, and it moves out and down over the land, and the air goes from the land over the ocean in the evenings and in the early mornings. Similar, because of highs and lows, just vertical here, are the katabatic and anabatic winds. Katabatic winds are also called mountain winds because they're coming off the mountains at night. It's cooler up there. The tops of the mountains lose their heat faster. The wind gets the air gets heavier, and it moves down slope into the valleys. The anabatic wind is the valley wind. The mountaintops, the thinner air gets that heat and sunlight first, so it starts warming up earlier than in the valley. So it heats up faster. So it starts rising. The air from the valley moves upslope to fill in that gap left by the rising air at the tops of the mountains. We have a couple of other types of winds here. We have the fall wind, when dense cold air flows from higher to lower elevations due to gravity's pull. It's not necessarily because of mountains in this case. It could be from other geographical features or just some differences in temperature that occur between the different altitudes. We also have fanes. Yes, it's pronounced fanes. I know it's an O and an E, but it's pronounced with a long A. These are warm, dry winds that travel down mountain slopes. One of the more prominent ones is the Chinook winds on the eastern side of the Rocky Mountains. These are fanes. Yes, I know there's a casino named Chinook Winds. Well, that's where they got their name from. And then we also have another localized weather wind here, the Santa Anas in Southern California. These are very dry and often dusty winds blowing into Southern California, I believe from Arizona and Nevada, over Arizona and Nevada into Southern California. This is very dry. It dries out the grass and any other vegetation, which makes it very easy to catch fire. It's one of the reasons why Southern California and those areas are very prone to forest fires, is because of the Santa Anas. So this actually ends Chapter 7. We will have a test soon. Go answer the science video question, and I will see you in class.